Okay. Hello, my name is Andrew Fox. I am a network and computer security major here at SUNY Poly, and today I'm going to be talking to you about open source 5G network deployment. So, before I get into my project, I need to explain what 5G is. It is the 5th generation of mobile networks. Compared to 4G, there is a 100 times traffic increase, and also it's in high demand. Because of its high bandwidth and low latency performance. OpenAI Cellular is a collection of open source tools that allow you to basically run your own 5G network on your own device. Now this can be ran on a laptop, a PC, a server, pretty much anything that has Ubuntu on it, you can run OpenAI Cellular on it. So some of the goals for my project are to install and deploy OpenAI Cellular, which I was very fortunate enough to have access to equipment that I can use, multiple servers that I use to install OpenAI Cellular on, and was able to basically get that hands-on experience that I need with that equipment. So I'm thankful for that. Run OpenAI Cellular components. I'll get into that in a little bit. An attack against the 5G network. I wanted to run an attack against this network, and I wanted to see how it would perform while under a lot of pressure and under an attack. And in student experiments, I think here at SUNY Poly we don't get to talk too much in detail about mobile networks or 5G networks. Yes, we talk about wireless, like the wireless classes here and things of that nature, but we don't really get to dive deep into mobile networking. So I think this is a great opportunity for students to use OpenAI Cellular to learn more about 5G and mobile networks if they're interested. So some of the technologies that I use to deploy OpenAI Cellular, so Docker and Kubernetes were responsible for the deployment side of things. We have Helm, which is going to manage all of the packages involved in this project. SRS RAM project is what we're going to be using for the simulation part of the 5G network, and all these go together and form OpenAI Cellular. Now, there are multiple components that go into OpenAI Cellular. On the left side of the screen, I know it's kind of hard to see, the images are kind of all messed up on here, but on the left side of the screen is the EPC, or what represents the core of the network. There is a lot of useful information that comes out of that. It's basically used kind of like as a logs for everything that's running, and it has, again, some very important information on there. And then on the right side of the screen, we have the G node B, or the cell tower, that's going to be, sharing its signal to all the devices that are going to connect to it. And this also provides us with some very useful information. I'm going to zoom in on this picture. It tells you when users are connecting, disconnecting, and also it tracks the network metrics that are going on within the cell tower. And then the last component that we have is the UE, the user equipment, the actual devices that are going to be connecting to the cell tower. And again, all these terminal windows that it shows for each of the components all share some very important information, especially for researchers who are looking to learn more about what goes on in a mobile network. And I'm going to zoom in on this picture for the user equipment. It tells you the IP address of the device that's connecting, and it also tells you some information about services that are going on. RRC is connecting, it tells you when things are connecting, disconnecting, configuring, reconfiguring, things like that. So again, very useful information for us. Now, what I decided to do for an experiment while utilizing OpenAI Cellular is to basically run a denial of service attack against this network. I use a tool called hping3, and it just floods whatever the IP address or the network is that you want to attack, and it gives you some information such as bit rate, ping response time, a bunch of other things. So the first metric that I captured was the bit rate over 2 hours. So for 2 hours, I ran it in normal conditions, users connecting, disconnecting, things of that nature. And then for another 2 hours, I ran the same thing, but with the denial of service attack. And as you can see, the bit rate had a slight decrease. If you look at the overall average, slight decrease, but there's more spikes that go close down to 0 throughout 2 hours, meaning obviously the attack had some effect on the network. And then a second metric that I decided to capture was ping response time, and this was during while pinging the cell tower. And again, same thing, 2 hours under normal conditions, 2 hours denial of service. And while running the denial of service attack, I noticed that there were some huge spikes where in response time going above 750 milliseconds at times. So again, this tool definitely had an impact on the network. It didn't go completely down, which is what I was thinking would happen. But again, there's still some slight performance issues while under an attack. Now, exploring further, there's some things I didn't have time to do while working on this project. OpenAI Cellular offers a testing platform actually, where you can run scripts, you can collect even more network metrics if you wanted to. I didn't have time to really get into it and use it more, but that's something that I would have liked to do. And then I wanted to run at least one more experiment with it to test it out some more. I wanted to run a man-in-the-middle attack against this network. Some of the tools that I was looking into had some issues, and there were some compatibility issues with OpenAI Cellular and some of those tools, so I didn't really get to go deep into that, but that's something I would have liked to do. And yeah, thank you so much.